Hey guys, it's Vince. Today I'm in the lab and I'm working on a client's plugged cable. And again, a plugged cable, just so everyone's aware, just has the one end soldered on, which of course is the female spindle power plug. What I want to cover is, again, here is our solder joints. And these solder joints are done correctly. You guys can see that. And you see the difference in the color of these joints. You can see how it's level all the way across into the cups. Okay? You can also see how the cable is, once again, properly insulated in that the double shields are all pushed back within the casing, once again, so we have no potential room for accidents. Now, that being said, there are other people who are selling cables who obviously know that they apparently have internal shorts. And when I say an internal short, that means that one of these power leads, and there's three, you can see black, white, and red. These are all power leads, as this cable is three-phase. They know that there is the potential, or they've had issues in the past, with one of these leads making contact with the ground lead. Now, for my electrical guys out there, you're shaking your heads and you're going, oh my God, as did I. And I cannot emphasize enough, be very careful when you buy these cables. When you see a cable that's under $200 that's supposed to be double shielded, if it is, we don't know. If they claim it's double shielded and they're doing this kind of work, and when I say this kind of work, it better look like this. Because if it doesn't look like this, you just got screwed. And I'm just putting it mildly. Okay? I'm not afraid to show my work on camera because this is years of experience. This isn't a day. This isn't an hour. This is years of experience. And I can tell you right now, I'm not cheap. And I'm not cheap for a reason, because I'm protecting you, your family, and your assets. And you can see that right here. And I don't put what you're seeing on your screen right now as a warning to my clients. And you've got to read this to believe it, because I couldn't believe it. And I'm not going to hide the vendor, because in this case, this is openly available on their website, which is what I call despicable. I don't think you should be letting the public know that it's okay if your cable has a short from one of the power leads going to the ground. And then to say you're going to continue to sell these cables to the public who may not be aware of what that means. That is an extreme fire hazard. I could care less if the VFD could handle it. I'm telling you now, if this cable isn't built right, guys, and you have a fire, you better hope to Jesus that you are going to be covered under your insurance. Because if a fire marshal has an insurance inspector go out there and they find out that a cable was faultily built or a cable is at fault, they're going to look at it in an unscrupulous manner, and they are going to make sure they do everything in their power to not get you paid. Fact. It's a fact. So, again, looking at this, because once again, this shows you experience. Watch this. You can see the gap we have here with our cable between our leads. The gap from here to here. This is double wall heat shrink. And again, I have some guys that'll ask about insulating each individual lead. How is that practical? This is going to be inside a casing. Any connector that's within a casing, whether it be DB25, DB9, you'll see these guys trying to insulate these leads. That makes no sense, because, once again, the end user has no way of actually contacting these leads at all if the cable is built correctly. This is a double wall adhesive heat shrink. If this is cut properly, it will fit like a glove. Watch this. And you can see, I'm seeing if I can just hold it for the camera so you can see it. Done. Now, when that shrinks, we are going to have a perfect connector. Okay? And I've said this before, this is years of experience. This is not a day, a week. This is hundreds and hundreds of cables, if not thousands at this point. And I'm telling you right now, that's what my clients pay for. That's why I draw the clients I do. They understand the value in that, the value in safety. I'm making you aware so you understand what you're dealing with. This is serious, and I cannot emphasize that enough. Okay, you can see right here where we have no gap now between our casing and our double wall heat shrink. Everything is all the way up to the terminals and seated properly. Once again, with the adhesive on the heat shrink, this is locked into place. Now, double wall heat shrink is much different than standard heat shrink. You can see here just how thick that wall is. And this becomes more or less a polymer of plastic once it's cooled. And that's why I prefer double wall on any connection like this, because with the adhesive, this insulation will not move. And that's exactly what we want. And you can see how our cable meets up exactly as it should. That's not luck, guys. That's a lot of practice. I cannot tell you that enough. So if you're purchasing a spindle cable, my recommendation is, and you have every right to do this, just ask him for a picture of him either building it, of him either covering in explicit detail what to expect. Know what you're buying. Your money I'm trying to protect. So think about that before you leave a comment, because some guys always try to, I think, misappropriate what I'm teaching you. And what I'm trying to teach you is what to look out for. You can buy from anyone you want. It's not going to change anything. The fact of the matter is I know there is no one doing this kind of work by hand, and it's required. Please excuse the pump. Okay, guys, in this video, I want to cover briefly a GX16 6-pin connector soldered properly. First and foremost, I'm going to see if I can show you this easily on the camera. You can see your shield drain allocated to pin 6. You notice how all of, right there. There we go. You can see how all of the solder is the proper chrome color in terms of it filling all of the pockets on the connector. Once again, Flux, Kester 186 RMA, and you can see here how this cable is done, and all leads are done exactly the same. When I get asked, and this cable is going to a client in Australia to once again be an interface cable for his Masso and VFD, when I get asked, why are these cables so expensive? Look at the tolerances I'm working with here. I want you to see that this, again, is a probe. Look at how small this is, and look at this tolerance as far as where that shield drain from the cable is going to pin 6. Now, I have guys that go, well, why do I need to allocate the shield drain to pin 6? Well, you don't, but here's the thing, and this is where experience, I feel, comes in. You'll notice your leads all go around the connector symmetrically. It's arbitrary as to what color lead you assign to what pin, because it's only going to matter to your particular system, unless you're building systems and selling them. The thing to keep in mind is you want to have your leads balanced in terms of they're not under any stress. So each lead independently goes to a terminal. You can see that right here. And you can see how all the colors are under no stress, the casing's all perfect, and therefore that's why we allocate the shield drain right in the center. That's very, very important. Once again, if I come under the light, you can see exactly what these connectors are to look like when they're done. And you also see no exposed shield, meaning the tin braided copper or mylar foil coming out of the casing. We do not want any potential for ground or interference, and that's exactly the way this cable is once again to be built. And that's also why it's so expensive. Keep in mind, guys, Flux right now is very, very expensive. Solder, Kester number 44, that is the one I'm using, and I'm telling you right now, we don't cut corners on any of our raw materials, and the quality of the product speaks for itself. But I'm telling you, if you've never soldered a 6-pin connector, these are very, very tedious. You have to know what you're doing and move very carefully, or you will have issues. Okay? But if you look at my fail video series, and I hope you do, you'll notice none of their connections look like that. None of them. And I'm not putting them down. I'm saying that when you use the proper process and the proper tools, and once again, the Flux and the solder is considered the proper tools in conjunction with one another, you then have really, in essence, all of the required accessories to get the job done correctly. And you can see exactly what we've got. Okay guys, I'm on the bench again and I'm working with a project for a client. This is my large ground bus. And when I say large, it's professional grade, it's copper. I'll put it on the screen so you can see exactly what I'm building here. I'm actually building the grounding strap for this unit. And you can see we've got 1/2-inch tin braided copper here. And this is the grounding strap you should be using on large machines, or any machine for that matter, that you want to ground with the most material possible. When I say most material, naturally, the more copper material we have, the thicker the gauge cable, so to speak, the better grounding you have. This ground strap is, once again, designed for that. And I'm actually putting two pieces together, and I'm going to be soldering it right here in this SCA connector, which is, once again, in the vise. In my hand is the piece of solder I'll be using to, once again, join these components. This is the SCA connector. It's much larger than any connector most of you will use on your systems. I'm also going to be using double wall heat shrink to finish this ground strap. Stay put soldering jig holding in a perfect arc coming into the connector with these connectors mounted in the vise. The vise, of course, does have the V-groove, so it makes it very easy to hold these connectors. And you can see how we have all of the tin braided copper bottomed out. This connector has already been tinned internally, and these are tin copper already, but they're very thick. So being they're very thick, we need a strong soldering iron. When I say strong, lots of watts. And again, this Weller is designed for more industrial soldering. Now, I actually built this tip because I needed more heat. Okay, and this is just copper bar, more or less. And once again, I just folded it over in the vise carefully, and you can see you can make your own tips. So if you guys are serious about learning different soldering methods, this is something you can do yourself. You can see the lights come on, and this unit is highly ready to go as far as being active right now. So what I'm going to do is take the Kester 186 Flux and do the same thing. We're going to saturate this, and I'm going to drop beads on both ends. So you can see we've got a pocket here, and we're just going to hit this carefully, let it just fill. Okay. Once it starts dripping over onto my mat, I know I'm golden, I'm saturated, and I'm ready to go. Now I just need proper heat. Now I cut the piece of solder, this is Kester number 44, and I cut this approximately 6 to 8 inches, and what I'll do is I'll feed this so that I'll get the proper beading. And what's going to happen, because I'm using the proper flux, is you'll see that solder go in, and as the heat penetrates, you'll see the wicking action where it'll just level. So first side I'm going to hit is this side, and I don't know if she can get that so easy. I'll let her get in a position. And what I'm going to do is take the iron and just heat right here and put it right in that groove. You can hear it, and now we're just filling. Let that heat up, and I'm just going to stop filling for a second. Now I'll fill again. Let this go. What you're going to see is that solder will wick itself right in as it gets hot enough, and it will penetrate. There we go. Just holding the iron there, no pressure. Okay, and there you go. You can see right here, that is perfectly filled. We'll let it cool for a second. I'm now going to tack the other side, and this has been totally filled up with solder. And come on this side, do the same thing. This is why you do not see these being made or offered by anybody else, because they are labor intensive. And again, you can see the jigging that's required. This guarantees that his ground bar will offer the least amount of resistance, because we have the most amount of mass as far as conductive material going to the ground bar. So once again, I'm going to come in here, I'm going to fill that up. I'm going to heat this. Now this is a little trickier because, again, I'm going to come in lefty. And I'm just going to heat right here. We're already set to go. Applying no pressure, putting the solder in the joint, and letting that just wick in. Hold it. Not adding too much. I want to let it do its job and just let it heat the part. As it heats the components, it will fall in. Of course, I do have a fan going and I am in a well-ventilated area, so if you are soldering, I highly recommend that. Just holding it 1 second. So you can see how, once again, doing this, it's going to take some practice. And once you get it right, you'll know, because of course you could do a stress test just simply pulling on this. Tin-braided copper, you're certainly not going to break. Okay. Now if you look, we're getting it to flow perfect, but we have gaps. And I'm doing this for a reason so you can see it on camera. I'm sure she can see that on camera. You got that, right? Mm-hmm. So you can see that gap right there. So we want to naturally hit this again with more flux. But what you'll notice, and this I cannot emphasize enough, you see me do small connectors, now I'm doing a large connector, is just how fast this is corrected when we add flux. Because what's happening is we're getting that wetting action, the flux is wicking in, and like water, it penetrates, and now as we add more solder, it's going to go in and pocket that, and everything will be beautiful. So I'm coming again, I'm going to come in lefty. Over the years, I've become ambidextrous with soldering because it's just easier. Coming in again, heating the component. Now we'll start beating the joint again. And you can hear the sizzle. And when you hear that sizzle, we're doing it right. Let it go. Don't rush. Keep your hand as steady as possible. And let that solder do its job, and it will penetrate. There we go. Right there. Right in. Now leave it for a little more time because we have both sides now soldered. And we want to make sure we have full penetration all the way in. Just putting pressure on the vise. And I'm coming in. And there we go. You can see how that solder is just going down and down and down. And that's exactly what we want. Release heat. There's your cup. We'll butt that joint up. We'll add a little more solder. You can see how it's pocketed level. We're going to come in with a little more flux. You can see the sizzle, and it's cleaning right now as we're doing this. Done. Got it just about right. Make that butt joint nice. I'm just going to finish it right here. You can see it slowly wicking down, and that's exactly what we want. And there you go. Hit a little more flux. But you can see the chrome finish on this is absolutely beautiful. And that's exactly what we want. We know the part is clean, and we're getting a perfect joint. Coming again. Teeny bit. You just stay here and carefully hold it. We got it. There you go. And there's our joint. You can see just how perfect that came out. Totally level. Everything is filled. We'll let it cool. There is no pocketing there. This will be cleaned, and that's a joint that's ready to go. Of course, then I'll just slide over the heat shrink, and we'll have a finished component. I will show you this when it's completed. I love my stay put, and that's the easiest way to do this without having any issues. But you can definitely see here, pop this out, pull it out, full of flux, and you can see that joint on top. And I'm pulling on this, and that is bonded. Everything there is flawless. You can see how we cupped it, and you can see that joint, just how perfect it is, and you're all set to go. Now that client, I know, has got a cable that will last forever. You can also see that the tin-braided copper is properly bottomed out in the SCA connector. Right there. So again, when we talk about grounding, This is the best grounding material you can use. It's definitely not the cheapest. It's definitely not the easiest to work with, especially when you're soldering components like I am. But if you're serious about grounding, you want the lowest ohms rating you can get, once again, resistance, this is going to provide that, okay? Because you can always triple this. I've never seen a requirement to do it, but you can go as thick as you'd like, as long as it'll fit within your connector. Okay, so you can see, of course, the connector has been cleaned. Everything is done. This is ready to go. We're going to apply the heat shrink. We're going to come right over that edge where, once again, we've got that ridge line. And we're just going to go right about there. And we're set to go. Grab our heat gun. It's going to get a little loud, so excuse the noise. Try to do this in an even fashion. Now, double wall heat shrink, you will want to heat more than regular heat shrink because, again, it's double wall. And you can see just how thick that is when that comes in. Look at that edge. So everything here is perfect. We are now done with this connector. I will move on to the next connector, but you can see just how nice this strap comes out when it's done. And this is forever, gentlemen. This will not fail under normal use ever. Because, again, it was built properly, once again, using the proper flux and the proper solder with the proper heat. And that's why I say it's always good to have an assortment of soldering irons as well as tips. This tip is necessary to get the amount of heat required for these connectors. But when it's done right, it's done forever. And this is not going anywhere. So I'll switch this over, I'll knock this out, and I'll show you the finished component when it's done. All right, guys, here is the finished assembly. And these units I do not sell that often, believe it or not. This is over 1.5 pounds of pure copper. Okay? You see the SCA terminals attached. This is a 2500 volt rated ground bus. And you can see how the ground strap now is attached. We've got the Flux 179 True RMS multimeter right there. Now keep in mind this unit is hand assembled, polished by me, and of course, every connector has deoxit gold applied to it. Any build I do before it leaves the shop has deoxit gold. Ask your vendors if they use it or even know what it is, because honestly, most of them don't. This stuff is used by at least 50 Fortune 500s, including NASA. Check it out. It's in my store. Every connection, once again, that leaves my shop always has that attached to it. But you can see the finished product right here. Client's all set to go. He's got his terminal lugs all there. Here is the ground strap fully assembled. And let's see what we got as far as the ground rating, as far as continuity. Just going to put one terminal here. And we should be zeroed. Boom. Make sure I'm holding it on. There we go. Full continuity testing to make sure everything here is golden. We'd see our contact point, of course, dead on. Everything here. This will once again assure the lowest possible resistance to ground. And you can see we went with a 2-foot strap, and that once again keeps this nice and short that he can mount this anywhere on his chassis that's required. And once that's done, he then has the proper ground split, which is the star point ground system. You see here, it's just larger. And then he would attach leads from all over his chassis, grounding it. And that's essentially what we're doing. If we come here, here, you can see once again, everything right where it should be. That largest amount of mass is what we want, because all we want to make sure of is that we dissipate any potential EMI to ground as fast as possible. Once again, putting the oxide on here, that'll keep these connectors perfect. You can see that slight gold hue. I don't know if you can get that on camera, but it's got a slight gold hue. All the threads have it applied, and in this way, he's golden. Now, the big question here is that when you install this, because I get a lot of questions on this, Loctite should, you can see just how sensitive, Loctite should be applied to your threads. And why I recommend Loctite, and when I say Loctite, just so we're all on the same page, let me just turn this off. Why I say Loctite is we want to make sure, a little dirty, let's keep it clean, right? This is the one you want to use. Loctite 242, this is known as the blue Loctite so that your parts can be removed. That's what we want to use. Why we use Loctite on every component on your CNC chassis, and it's interesting because not many vendors even discuss this, and I don't understand it. Vibration is always going to be prevalent, and once again, regardless of what you're mounting to the chassis, this should be applied to any nut that is not self-locking. If it doesn't have a nylon insert in the nut, you should be using this. Okay, so again, this client's all set to go. Ian, I want to thank you again for your support because this is your actual unit, and you will be receiving this in the fully assembled format. All you'll have to do, of course, is install all of your leads going to your chassis, and you're golden. And once again, you can see all that tin-braided copper. So mass makes a difference, guys, when you're going to ground. And I say that all the time. So if we have more conductive material, which again, we have tin-braided copper here, 2 of these straps is way more conductive material than the largest gauge wire. You can see just what we've got here. And these are industrial connectors with the SC8s. So looking at this once again, that shows you the finished product. Thank you all for your support. Take care.